thinking too much. With adding and subtracting any fractions, whether or not they're rational expressions like we see here or not, you have to have a common denominator. And that's usually the part that requires the most work, is figuring out, okay, what do I have for a common denominator here so I can put these together? So we have to think this way, and it's tough after doing all of that canceling. We cannot cancel these as we're going through the process. If, when we get done at the end, we see something that we can simplify, well, yeah, that's simplifying. We could cancel something out. But you don't cancel as you're going through the process of building up your fractions to be common denominators. So we're going to use our objective here of just adding and subtracting rational expressions, which doesn't sound too scary. But because we went over all those homework problems, I'm just going to go ahead and skip that little getting ready that we have there. And it says we can use common multiples. If you remember from elementary school, usually we're trying to find least common multiples or greatest common multiples. And have you do those to figure out, what would be the smallest thing we could build both fractions up to be. So common multiples to add and subtract rational expressions. Also use common multiples of numbers to add and subtract fractions. That's what we do. That's what we do. Have to have a common denominator to put them together. So our essential understanding is to operate with rational expressions. You can use much of what you already know about dealing with fractions. It's not brand new. Common denominator. Hopefully least common denominator. If it's the least common denominator, it's going to make the math easier. Anytime we're dealing with smaller numbers, the math will be easier. Jessica, what's that? Pay attention. In a best case scenario, we use the least common denominator. The first step is going to be to factor your denominators. We need to see what are we working with here. And then think, how are we going to build these fractions up so that they have the same denominator? And that's why it's so important that we factor to start with. If we miss something and we don't factor it, we're not going to have the least common denominator. Like I said, the math is much easier when you have the least common denominator. Then we must have every piece of the denominator, so everything has to be there for that least common denominator. And we need it to its highest power, because we can build fractions up to make them match each other, and then we can get a common denominator and put them together. So that's all the yakety-yak from this section that we're already at an example. It's like, you know what to do with fractions, just make it happen. That's what they say, but it is a little more complicated when you start throwing algebra in there, like it's complicated because of the fact that we're going to do our factoring. So this says what would be your least common multiple for this big mess and this big mess. I'm going to do two colors here so we can see those two expressions. Well, here's what we have to remember. Every piece has to be there. So I look at these two and I see we're going to have a number part. We're going to have to deal with the 12 and the 18 and try to find the least common multiple for those. We're going to have some stray variables. And we're going to have to take those and we have to take them to their highest power. We're also going to have some factors. And we're going to have to take those and to their highest power. Now, for the 12 and the 18, you used to make factor trees and all that stuff in elementary school, but chances are pretty good that at this stage of the game, you kind of go through your mind and say, okay, let's see, this got easier when I remembered that really all I have to do is think of all the multiples of 18 until I get one that's divisible by 12. Okay? So 18 times 1, 12 won't go into that nicely. 18 times 2, that's 36. Oh, 36, it works. 36 will be my least common denominator for just the 12 and the 18. I'm going to need that. Now the stray variables. Well, I have an x squared and I have an x. I have to take the highest power because I have to build them up to be the same. So it's going to have to be the x squared. Then I look at my y's, and I see I have a y, and then I have a y to the third. Again, have to take the highest power to build those denominators up. Because to get those common denominators, we multiply the top and the bottom of the fraction. So there's my stray variables. There's no other stray variables anywhere up there. And then the next part is, okay, if we do factor x squared plus 2x plus 1, what do we get? Well, hopefully when you look at that, you're thinking, hey, that might be a perfect square trinomial. This is x squared, and this is 1 squared. 1 times x is 1x, and if you double it, you get 2. Hey, this is x plus 1 squared. Now that's important, because remember, we have to take everything and we have to take it to its highest power. Then, my blue one up there was x squared plus 5x plus 4. I can check to see if it's a perfect square trinomial, but this one isn't. It's x squared, it's 2 squared, 2 times x doubled is not 5. So this one, we're going back to old-fashioned factoring, and we're finding two numbers that multiply to 4 and add to 5, and that's going to be 4 and 1. Now, we have to have everything at to its highest power. We're going to have an x plus 4. If it's in one of them, it has to be in that least common denominator. So x plus 4 is going to be a part of our least common multiple. We're also going to have x plus 1. You can see it, it's there. In fact, to its highest power, we're going to have to take a 2. And we're going to be very grateful that this isn't an actual problem where we have to add a couple of fractions with these as denominators, because that would be a monster right there. This is just taking us through the process of what would that least common multiple be. Everything needs to be there and to its highest power. Take a look at the guy. Give me a 4, 3, 2, 1, 0 on how comfortable you would be doing this with a partner. Okay, not high enough for me to say go for it, so let's do them together. We have 2x plus 4 and x squared minus x minus 6. These are things we can factor. So how do we factor 2x plus 4? Take 2. Anything special about x squared minus x minus 6? Nothing special. What are two numbers that multiply to negative 6 and add to negative 1? So, LCM. Everything has to be there and to its highest power. Do we have any numbers, standalone numbers? Gotta be there. Gonna have to have the 2. Do we have any standalone variables? Nope. Now, we have to have every factor that's there and to its highest power. Notice, this was to the first power and this was to the first power. There were no multiple powers here. So we're going to have an x plus 2 to the first power, and we have to have an x minus 3. Everything has to be there and to its highest power. So this would be what we would build up for least common denominators for those two fractions if we had to. B has 3 of them. Oh my goodness. All right, let's look. We have x squared plus 3x minus 4, x squared plus 2x minus 8, and x squared minus 4x plus 4. Well, we can't find an LCD unless these things are factored. So, I'm thinking, anything special about the first one? That's a negative 4. It has to be positive to be a perfect square. So, this is just going to be normal, good old-fashioned factoring. Give me two numbers that multiply to negative 4 and add to 3. X squared plus 2x minus 8. Anything special about that? Nope. Two numbers that multiply to negative 8 and add to 2. last one, x squared minus 4x plus 4. Anything special about that one? Yes. It is a perfect square trinomial. This is going to be x minus 2 the quantity squared. Now, let's just say you already factored it and you had x minus 2 times x minus 2. You'd notice that. You would notice it. Then you go, oh, wait a minute, I need to do the power thing, so I need to have it as x minus 2 squared. So, blue, green, and red. Any spare numbers hanging out by themselves anywhere? How about stray variables wandering around without other stuff attached to them? Good. So that means all we have to do is take each factor into its highest power. So what's one of the things we have to take? X plus 4. Gotta be there. What else? Gotta be there. Anything else? Good. We have to have it squared. We have to. Everything there to its highest power. And once we start working on these, that'll just become natural. You'll see, oh, this will be my least common denominator because I can build these denominators up to be the same thing. So that's what we do. Least common denominator of the fractions is also the least common multiple of the fraction. So that's why we spent our time just figuring out what is that least common multiple. Well, let's use the smallest thing that we possibly can. So if we had a little fraction like 1 over 8 plus 1 over 10, yeah, they went a little overboard because what they're doing is the whole factor tree thing. They're saying 8 would be 2 to the third, and 10 would be 2 times 5. So if you had to find a least common multiple for those two, you'd have to take the 2 to the third, and you'd have to take the 5. Well, that'd be 8 times 5, so your least common denominator would be 40. Least common multiple and least common denominator would be 40. So then you build up your fractions so they both have a 40 on the bottom. This one was 8, so it needs a 5, top and bottom. This one was 10, it needs a 4, top and bottom. So you get 5 40ths plus 4 40ths, which is 9 40ths. The process is the same, but the factor tree thing, I think, messes with some people's heads. So kind of ignore the whole factor tree thing. As we go down here, now we get into it. How are we going to do this? Well, it all starts with finding that least common denominator. What is the sum of the two rational expressions in simplest form? We're adding, we need an LCD that state any restrictions on the variable. So the first thing we're going to need to do is factor any denominators that aren't already factored. This one's good to go, but not this one. And even if the numerator were factorable, I wouldn't factor it. This isn't about the numerators right now. This is about, let's see what our least common denominator should be. X squared minus 3x plus 2. Greatest common factor? Can we pull something out? Nope. Perfect square trinomial? Nope. What do you have for the two numbers that multiply to 2 and add to negative 3? Now that we did for two reasons. First, we need to know what the LCD is. And second, we need to do domain restrictions. So I'm going to start with domain restrictions and get that out of the way. What numbers are out? 1 and 2. So now it's LCD time. We need everything and to its highest power. Okay. Any numbers hanging out in our denominators by themselves? Any stray variables, x's and y's with nothing added or subtracted? So now it's just factors. Factors to their highest powers. What are we going to have? Have to have an x minus 2, then we have to have an x minus 1. We absolutely do. So now our job becomes, how do we get that? How do we make that happen? Well, this one already has them. We're going to have to do anything there. Now what I need you to do is this, because I want your notes to make sense when you look at it later. You're either going to change colors right now, or you're going to rewrite this. I'm going to do both. I don't want you looking at your notes later and saying to yourself, oh my gosh, I don't remember what on earth we did at this point. One of these isn't ready to go. Which one is it, the first or the second? The first one. So we say, well, this has the x minus 1. That's great, but it needs an x minus 2. And whatever we do to a fraction on the bottom, we have to do to the top. We have to. And that's to keep it equivalent. We really have just multiplied it by 1 because x minus 2 over x minus 2 is 1. Now, I'm going to distribute my numerator. I'm not going to distribute my denominator. And I'm doing absolutely nothing to my second fraction. This is the stop and think step. 2 things to stop and think about right now. Do we have these now written with a common denominator? Excellent. We have to see that. We have to see a common denominator before we can actually put them together. The second is, did we miss any restrictions on the domain? No. The fact is, once you've found that least common denominator and you've given the restrictions on the domain, you've got them all. I mean, those will be your restrictions on the domain. So now we finally have a least common denominator. Remember, that means our answer is going to be over that LCD, least common denominator. Now we need to do the math on the top and see what we have. Well, we have an x squared. We have minus 2x plus 2x, so that's going to be gone. And we have a negative 1, so x squared minus 1. Now and only now do we want to see if we can cancel anything. That's only going to happen if we can factor x squared minus 1. Is that factorable? It is. X squared minus 1 is a difference of 2 squares. That's going to be x plus 1 times x minus 1 over x minus 2 times x minus 1. And we can see the x minus 1s are going to cancel. And there it is. X plus 1 over x minus 2. Much longer process than what we dealt with when we were multiplying and dividing. We have to tear everything apart, find the LCD, build the fractions up, put them together, and then and only then do we check to cancel. You've got those lines on the side over there. I want you to write down right now. Only cancel as a last step. Only cancel as a last step. We have to see what our numerator looks like after we have that least common denominator in order for us to see if we can cancel anything. So there's no canceling as you go through the process. It's the last thing you do. With multiplying and dividing, you can think of it as kind of the first thing we do. Try and see if we cancel all this and then get an answer. But here, it's get an answer and then check to see. So this is, what is the sum of 2 rational expressions in simplest form, and state any restrictions on the variable. Do it all right. Comfort level, okay? Because I kind of like to let you guys try and do these. 4, 3, 2, 1, 0 now. Stuff. Those are better for working together. I'm going to let you loose here for A and B. So start your factoring of your denominators. Bless you. Trying to find those least common denominators. Those walk around. It looked like this first one. Not much of a problem. Most of you went through and said, hey, I'm going to factor out that x squared minus x. Some of you, though, kept the whole thing. And what you want to do is remember, even greatest common factors help you have that least common denominator. So our LCD here, once they're in factored form, is the straight x sitting out in front, and then the x minus 1. And again, if we do our job right, we should be able to get the domain restrictions right here, right now, and never have to add another one if we use that LCD. And then you build this fraction up with x's on the top and the bottom, so you have that least common denominator. you get yourself a nice little quadratic over here, which is factorable. So once you put that numerator together, you check and see, hey, if I factor that, is there something I can cancel out top and bottom? Last step, cancel. X minus 1 is gone, x plus 2 over x. Again, no new domain restrictions. We already had x can't be 0, so we're taken care of. Second one, seemed like it had a little more to it, but not really. You know, we've got x squared minus 4, which is the difference of two squares, so x plus 2 and x minus 2. This one already had the x plus 2, so LCD, each one of those, domain restrictions, positive and negative 2, build up the second fraction with the x minus 2 on the top and the bottom, and of course when you multiply that by the 1, you just get x minus 2. So now you can combine. You have a least common denominator, and it is a common denominator, so you can put them together. And we have x plus x is 2x minus 2 over that LCD. And it is factorable, so 2 times x minus 1, but then you say, well, that didn't do me any good. So then the question becomes, okay, Cedarholm, should we just have stopped here? You know, are we supposed to rewrite it so it looks like this? The answer is absolutely not. This tells me you knew exactly what you were doing. You got to that last step, you saw there's no common factor that I can cancel out of this thing, but I did it, I checked, and then you're done, and you have it. So C says, is it possible to add the rational expressions in problem 2 by finding a common denominator but not the least common denominator? Talk to your partner. See what you think. If we, the question really is, if we have a denominator that's really too big, we make a mistake and we use a denominator that's too big, is that okay? Is that something we could fix in the end?
Yeah.
Yes. At the very last second, we'd go, oh my gosh, I could cancel this out. I didn't notice that didn't need to be there before. So can we do it? Yes. Yes, absolutely. So can always have too big a denominator. You just can't have a denominator that doesn't meet the qualifications of a denominator. So yes, we would just cancel at the end. You did an absolutely fabulous job of talking each other through this process of talking through that LCD and everything. Great job. Thank your partner for the wonderful. Now, 43210 me. How are you feeling about our adding and subtracting fractions?
I don't know, but I think we got a small line. Let's just say.
Okay. So we just need a little practice, and then the confidence will come with it.
Yeah, I said we seem like two problems going on.
2 problems?
Yeah.
Okay, can't do 2. But a lot, these aren't do the problem the whole way through. A lot of this 7 through 21 is just finding the LCD. You know, we started with that today, where we just broke them apart, factored them, and said, I need the number part, I need the stray variable part, and I need any factors to their highest power. So that is going to look a little scary, but it's not as bad as it looks.